Alright class, we're going to do some trig today, section 13.1. So let's get into the first example here. Evaluate trig functions. So you should know 6 trig functions. This is actually a review mostly in this section, if not all of it. So first thing, angle, this thing is called theta. That just represents any angle. Alright, it's kind of like x, instead of putting an x for this angle right here, we put a little theta sign. Okay, so we're going to find, you guys know sine, cosine, tangent. Sine of an angle. There's always an angle after sine. So that's why we're going to put this theta sign right here. Sine of some angle, cosine of some angle, tangent of some angle. Equals, equals, equals. Okay, sine, you guys remember as opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. There's 3 more trig functions. The opposite of sine, or the inverse of sine, is actually called CSC. This is called cosecant. Alright? That's what CSC means. Cosecant of theta is equal to, it's just basically the flip version of this. It's the inverse of this. Hypotenuse divided by the opposite. The inverse of cosine is actually secant, SEC, is equal to, the flip of this is hypotenuse over adjacent. And lastly, tangent, and there is cotangent of, I didn't mean to put parentheses, but whatever, doesn't matter, equals. And this one is flip this, and it's adjacent over opposite. Okay, so what are all these basically? Sine, cosine, tangent, and the rest of them are all ratios. A ratio is a fraction. A ratio of 2 sides, the opposite side and the hypotenuse, the adjacent side and the hypotenuse. They're just ratios, that's all it is, fractions. Just got to fill in the right ones. Okay, so because theta is up here, the opposite, it occurs opposite of the angle right here, 12. 5 is what we call the adjacent. What does adjacent mean? Adjacent means beside or next to, right? What's beside theta? This guy. Alright, so this has to be the adjacent side. This has to be the opposite side. And the other one is the hypotenuse, which occurs across from the right angle. But we don't know the hypotenuse, so we have to find it. So you have to know a squared plus b squared equals c squared is the Pythagorean theorem. Right, so basically this is a leg squared plus a leg squared equals the hypotenuse squared. So let's put in a. One of the legs is 5, square it, plus the other leg is 12. We square that, and the hypotenuse we don't know, so we'll just say that's c squared. Do some work, and this becomes 25 plus 144, which is 169 equals c squared, which means c equals square root of that, 13. So this hypotenuse is 13 up here. Now we have everything we need. We have all the sides, so we can figure out all these ratios right here. Let's do sine. Opposite of the angle over the hypotenuse. So opposite of this angle is 12 over the hypotenuse, which is 13. The adjacent to this angle, which is 5 in this case, over hypotenuse is 13. And tangent is opposite of the angle, which is 12 over adjacent, which is 5. There you go. Those are your 3 answers for these. And to get these answers over here, basically just flip them. 12 thirteenths, the cosecant would be 13 twelfths. Answer. Secant is the inverse of cosine, so that's 5 thirteenths, which makes secant 13 fifths. Answer. 12 fifths become cotangent, which is 5 twelfths. These are the answers to the second part. You just evaluated the 6 trig functions of an angle. What if the angle was over here? Then 5 would be the opposite and 12 would be adjacent. So you just got to pay attention where the angle actually is. That's example number 1. Make sure you understand it.